ambulance, and then that ambulance is releasing a sound, ne? Which means you are in the sound, you are inside the sound source, and you're having a detector, which means the frequency that you will hear, it is going to be equal to the frequency that is released. Okay. Inside the sound source. Frequency of listener is equal to frequency of the sound source. This is scenario number 1. But if you have a car, or let's say, yeah, an ambulance, let's just say an ambulance, and then the ambulance is moving away from you. Let me say ambulance. It is moving away from you, and then you are the listener, right? Which means the frequency that is released, by the way, you, the listener, you are actually the detector of the frequency, right? So in this scenario, the frequency that is released, frequency of the sound source, is greater than the frequency of the listener. Ambulance moving away from you. Yes, frequency of the sound source is greater than the frequency of the list. Right. I think my example might not make sense. Okay, take it for example. There is also someone here. The ambulance is having a patient. There's a patient here. They and then the ambulance is releasing sound. This one is releasing sound. What you're going to experience, you and the patient, you're going to experience two conditions. The patient, because it's inside the ambulance, is going to feel or to hear higher frequency. And then the listener, which is you, because the ambulance is moving away from you, you are going to detect lower frequency. That is why I said if the ambulance is moving away from you, frequency of the sound source is greater than frequency of the listener. That is what I actually meant by that. And then the opposite applies. The opposite applies when we have ambulance moving towards you. Towards you. And then you are the listener. In most cases, only one object will be moving. They will either say an ambulance is moving towards a stationary observer or a stationary listener, or they will say there's a stationary, or they will say a detector is placed aside the road. If they place an object aside the road, okay, this English, because you're complaining about English, take it for example. If when you go and place your bag aside the road, your bag obviously it is not moving, which means if they place a detector aside the road, the detector will not move unless they go and collect it. So you have to note that down, just in case maybe English is not English, because that might happen. And then listen. So now, in this case, ambulance is moving towards you, which means the frequency of the listener will actually be higher now. The frequency of the listener is going to increase. For this scenario, let me just say increase, because I can't say frequency of the sound source is less than frequency of the listener. I can't actually say it like that. So let me just say increase. Um, okay, let's see if my examples make sense to you. Okay, then here there is an example. They said a source is moving towards a stationary observer. It is moving towards. Oh, by the way, there is a formula that we actually deal with. That formula, it says frequency of listener is equal to V plus or minus frequency of the velocity of the listener over velocity speed of sound plus or minus the speed of the sound source, if I'm not mistaken. Yeah, and then multiply by frequency of the sound source. So this one is just frequency of the listener. But the only important thing in this formula, it is this one, the velocity, this V. This is speed of sound. Speed of sound. So if I ask you, or what is the speed of sound? Some of you are going to give me 340. Some of you will give me 343. Some of you will give me 342. Uh, yeah, they're both correct because the speed of sound, it is not constant. It can fluctuate. Yeah, speed of sound in air, it is on that range. So in every question paper that you will come across, they should give you the value of the speed of sound in air. If they don't give you, then the question is actually incorrect. The question has an error. You deserve to get free marks. So just in case maybe you got everything wrong, and then you can bring an argument with your teacher. They should have give us the speed of sound because we don't know the range. We just know the range. We don't know the correct value. It is unlike the speed of light, which is 3 times 10 to the power 8. This one is constant. It doesn't change. But this one, it can change. It's not constant. So in every question, you should be given that one. Then VL is just velocity of the listener. VL. This is the velocity of the listener. And then VS is velocity of the sound source. And then Fs is frequency of the sound source again, right? So I just don't know how you were taught this, but you can adjust the formula in many ways. I think you can adjust the formula in two ways, right? So let me write them down. When I will choose the one you were taught at school. Let me divide it into half. Let's say here, I will say if, oh, okay, when moving towards, they will say the formula should be FL is equal to V over, this is towards a stationary, let me say stationary listener, towards a stationary listener. So which means you are going to have plus 0, right? And then minus Vs, all multiplied by frequency of the listener, which basically means if you are moving, if a sound source is moving towards a stationary observer or a stationary listener, the velocity of the listener is 0. So it doesn't have an effect. Then your overall formula is, the formula that you can use is this one. You use it like this. But then let's say an ambulance is moving away from a stationary observer, moving away from a stationary observer. The frequency of the listener will be equal to V over V plus Vs, then multiplied by frequency of the sound source. This is scenario number one. when you are working with a stationary observer or stationary listener. So the velocity of the listener is 0. That is why I excluded it. Then towards, let me say stationary listener in this one. Then towards, let me say um stationary sound source. Then the formula in this one is going to be V, frequency of the listener is equal to V plus velocity of the listener, and then V, because the sound source in this case, it is stationary, so its velocity is 0. That is why I just wrote V. Then multiply by frequency of the sound source. Then let's say the listener is moving away from the sound source or the stationary sound source. We're going to have frequency of the listener is equal to V minus VL over V multiplied by Fs. So in your school, I don't know which method they showed you or which method they said you should use, but both of them, both scenarios, scenario number 1 and scenario number 2, they will give you the correct answer. So when I just pick on what you will be taught in your school, because you might confuse your teacher by bringing something new if it's not that, they're just teachers who are there for salary. So yeah, then then
I
okay,
have a
it's fine.
question.
Yes, you can ask.
So for the side of the stationary listener, I was curious on the denominator on why you said for towards it's V minus V and away it's V plus VS.
Wait, for the first one, okay.
Yes.
I mean the first one.
In the first one, the denominator is V minus VS, and in the away, it's V plus VS. I was curious on why in this equation it is that way.
I think this is how the formula is, unless maybe you were taught something different at school. They
I
did it
wasn't
the
taught
other way
this.
around.
No, I wasn't taught this concept yet, so that's why.
Can't hear you properly. What did you say?
I wasn't taught this topic yet at school. We're still currently at chemistry, so that's why I was asking.
Oh, okay, okay. So to answer your question, that question, but this thing has to the way we do it, the way we do it in this case, we need to make sure. Okay, let's interpret this together. Um, yeah, it's a good question. I yeah, yeah. I even did metric the entire year without asking that question to my teacher. And I never had anyone explaining that part. They just gave the formula. Just cram this. It's fine. Okay, but let's interpret this together. Let's say our sound source. Okay, let me simplify this. Maybe we can learn something from my statement. Okay, the formula is actually frequency of the listener is equal to V um multiplied by Fs over V minus Vs. This is moving away. I just took this one to the upper side because that's basically mathematics, basic mathematics. So what do we need to do here? let's work with the denominator only. Let's say maybe our sound source is moving at a velocity of 30 meter per second. We're just making an assumption. Our our sound source, the ambulance, is moving at a velocity of 30 meter per second. And then this V, let's say it is 340, speed of sound in the air. So if we say 340 minus 30, we end up with 310 meter per second. So what basically happens is that our denominator, it is decreasing, right? Our denominator, it is decreasing. Once our denominator decreases, it means our overall value is going to increase. Okay, look at this. I will make an example. Let's interpret this scenario, the second one. This one. We have FL is equal to V multiplied by Fs over V plus Vs, right? So we focus on the denominator. We're still using the same velocity, but in this case, it is moving away. So we say V plus Vs. We're going to have 340 plus 30, which is equal to 370. That is our denominator. So if our denominator increases, that means our overall value decreases. Okay, let's make an example and show you now. Or why? Okay, okay. Just that if I start talking about calculations, you guys are not going to you are not going to give me answers. I don't know what's wrong with the calculators. So I will make up simple values. Let's say I have FL there, and then maybe my velocity, let me say it is 5. I'm just making up these values. So it is going to be 5. Let me say the frequency of the sound source, it is 4. So I'm going to say 5 times 4. Then, because let me say this is two words, scenario for 2 words, then I'm still going to have 5 minus, let me say in this case, the velocity of the sound source, it is just um maybe I want a simple number. Let me use 1. Yeah, let me use 1 in this case. Or 2. Yeah, let me use 2. So if here my sound source is moving at a velocity of 2 meters per second, I'm going to subtract 2. So what I'm going to have now is 5 times 4 is 20. 20 divided by 3, which is basically, what is 20 divided by 3? Oh, I have a calculator. The 20 divided by 3. This is actually 6,67 hertz. That's my frequency of the listener. This is the frequency that I'm detecting now when the sound source is moving towards me. Then, but what if the sound source is moving away? What if the sound source now is moving away? I'm going to have FL equal to 5 times 4 over 5. I need to, when we said when it is moving away, we add. So 5 plus 2 is going to be 20 divided by 7. This is now 2,86 hertz. Yes. So that's the frequency for away. It was moving away from a stationary observer. From a stationary observer. So I want to ask you a question. What
Yes, sir.
can what can you actually conclude based on the frequency on these values?
So far, what I can conclude and what is explained, I can say that if it's going towards a person, if a sound source is going towards a person who is standing, then the value will increase of the frequency.
Yes, that's correct. So what actually happens is that if okay, it is simple. When you are listening on a radio, ne, when you move away from the radio, the frequency decreases. If you move very far from the radio, you are no longer going to hear any sound. Mara, if you move towards the radio, the frequency increases. Do you understand?
I understand, so thank you for explaining.
Yes. I hope everyone's fine. Are you all fine?
Yes.
Yes. So those are the adjustments of the formulas. They just want to ensure to make sure that the values of the frequencies will um behave in that way. Yeah. So it was a good question. It was a good question. I even came to a certain conclusion that I never actually know. Because for me it was just a conclusion and pass. Because I never saw the importance of this topic at all. All right, so let's try this example. Let's try this example. The sound source is moving towards a stationary listener, and then an ambulance is moving. Oh, this is a scenario for moving towards. This is an example, e.g., an ambulance is moving towards a stationary listener. The listener is stationary now with a velocity of 30 meter per second, right? Then the frequency emitted by the ambulance is 600 hertz. This is the frequency for the sound source. For you who said English, right now, this is the frequency for the sound source. The emitted means released in simple words. So the released frequency by the ambulance is 600 hertz. Then we calculate the frequency of the that the listener will detect if the speed of sound in air is 3 foot. So you can just first write the data of what you have. When you have the frequency of the sound source, which is 600 hertz, and then you have the frequency, you don't know the frequency of the listener, it's fine. You're looking for it. Then what do you have again? You have V, which is 340 meter per second. Then what do you have again? You have velocity of the sound source, which is 30 meter per second. What do you have again? You also have velocity of the listener, which is 0. Stationary means not moving. So the velocity is equal to 0 in this one, 0 meter per second. You are looking for the frequency of, you're looking for the frequency of the listener or the frequency that the listener will detect. Right. So you're going to just write the actual formula. First of all, write the formula that is on the answer sheet, which is FL is equal to V plus or minus VL over V plus or minus VS. You have to first write this formula. No makanjani. Don't ever just first adjust the formula because we don't know where you got the formula. Mara, if you adjusted the formula after writing the correct formula, now we understand. Or when you're a true scientist, who know what he or she is doing. So remember again, we're looking for the frequency of the listener, and the sound source is moving towards a stationary listener or stationary observer. So for a stationary observer, we're going to have V over V minus Vs over Fs. This is towards the stationary observer. Then from there, we're just going to make substitutions. Nothing much here from this point. If you understand the adjustment, then you just go straight and say 340 over 340 minus 30. Right, yes, and then multiply by 600. Then you get the answer. What do you get?
658,07.
Okay. I also want to make a certain conclusion. Remember, when I was first doing this topic, the first introduction, when I was talking about the frequencies, there is something that I didn't want to talk about because I assumed that I might confuse you because it was going to be a bit confusing. I want to show you something, that the frequency of the listener is equal to 658,07 hertz. But then the frequency of the sound source is equal to 600 hertz now. So what do you see? What I see in my case, the frequency of the listener is higher than the frequency of the sound source, which means when an object or the sound source is moving towards you, you will hear a greater frequency than the one that is being released. You understand?
Sir, please repeat.
Oh, okay. The reason why I'm saying about this statement, there's some question whereby you will be given both frequencies and you don't know which one is which. They won't tell you reduce the frequency of the sound source, frequency of the observer. They will just want you to interpret using the knowledge that I'm giving you now. When a sound source is moving towards you, let's say the sound source is releasing a frequency of 700, and that sound source is moving towards you. When you are going to experience a greater frequency, maybe 1000 hertz, this is what I'm saying here, Ori. When the listener is detecting a frequency of 658,07, but the actual frequency that is released is 600. Are you lost or are you fine? Okay. I know it's a bit weird. Someone is asking how, but that is actually physics. That is what physics does, what physics tells us. Mm, a better way for you to experience this. Take it for example, maybe there you are in a gig. Just that maybe you don't know you don't go to gig. Not go to gig. I mean bash, those things whereby we drink alcohol and stuff. Those speak what those radios that they play, the big speakers, you know about them, the DJ speakers, they release a greater sound. So if you move towards it, the more you move towards it, the actual sound that you are going to feel, it is going to be very much intense. I remember I was passing in front of this other speaker. That speaker even vibrated my heart, which means it was releasing a greater sound, or I was experiencing a greater sound than the released sound. Okay, it's fine. I'm joking. I don't drink. Let's talk about this one. Okay, a sound source now is moving away from a stationary listener, and then we still want the frequencies. Then, do you guys agree with me that the frequency of the sound source will be greater than the frequency of the listener. Do you all agree?
Yes.
You have to agree because now it is moving away. So, which means the sound that you are now hearing, the ambulance is moving away from you. The sound that you'll be hearing is going to decrease until it entirely disappear. But in this case, let me switch back to this question. In our case here, in the first case, the conclusion that I can say is that when it is moving, when a sound source is moving towards a stationary observer or stationary listener, the frequency of the listener is greater than frequency of the sound source. These are the conclusions. So these conclusions can help you when you are calculating because obvious on our calculation we got a value which is 658 and that value is greater than 600 which is the emitted frequency there. All right. Mara, this one, even though you are a bit lost, it doesn't change in all of the questions that you're going to get. You will adapt and you will see it's simple because it applies everywhere. Then for this one, now there's
Okay.
some, yeah,
Can I make sure that my train of thought is making sense with what you're saying? I don't know. But can I give an example of my own from what like something similar to what you said?
yes,
So from what I'm hearing, it's like when a taxi, you see those taxis that bump loud music. When you're next to that taxi, you're also going to vibrate with the music. The music is very loud, and then when that taxi drives past you, that's when you stop vibrating with the taxi. The sound becomes less, meaning that the frequency also becomes less and it goes further away. If that's what I'm hearing.
exactly that. Yeah, that's exactly. Yeah, you gave a good example. Now I'm not good with the examples, unfortunately, and I know myself. My example are always awkward. Yes, that's actually what happens when you're inside. You vibrate with the taxi. No, yeah, you remind me of when I'm going to Minati. Yeah, but uh, if you have that knowledge, that knowledge is going to help you even interpret the graphs because the only thing that is complicated it is when we talk about the graphs. Doppler effect graphs, they're not a child's play, to be honest. They are really confusing, but it's fine. Let's do this question. Let's do this question.
Okay,
Then,
so
um, when I just do the question and tell me the answer, cite the question and tell me the answer. And your answer should be less than, you should be greater than 450. That is where I will confirm or record the correct answer. Or you can just send the answer to my inbox so that I make sure everyone is understanding.
first I got my
Yes.
answer as I think it might be wrong. I
What did
got
you
it
get?
as so I got it as 35.
How much?
You see 35 is wrong. I think it's
635.
no 35, comma 471.
35. Okay, let's wait for the others. And yeah, if they get that one too, that means it's correct.
I got 419.
119. Yeah, that one I can agree. That one I
Okay.
can agree. I'm not saying it's correct. I can agree because the ambulance is moving at 25 meter per second. It is not that much higher velocity. Now I can even run at 25 meter per second. I'm joking. No, wow, I can do this one. Who else? 419. 419. Hey, come on, guys. Give me the answers so that we can move. Okay. Yeah, this is what you needed to do because when it is moving away, we said we add. When it moves away, we just add there. So it's 340 multiplied by,
Yeah, I
yeah.
got the same answer now. I've now got it fixed. It's 419,1718.
Oh, yeah. Okay. Yeah, it's 490, comma 18. You saw where you made the mistake, ne?
Yes, I said I made a mistake.
Okay. That's good. Very good. So those ones are simple. Those are not that much. Something simple. Yeah. This way you realize you chose the wrong subject. This way you will start when you're in exam, you will start to realize, or maybe I should have uh, chose history or agric because there's a lot that happens when you're writing exam in grade 12. You will see it during June. You have a lot of conclusions. Hey, 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 my future is no longer bright. So I'm joking. Sorry if I'm giving you guys pressure. Ne? There's nothing that will happen to you. You'll just be flowing. Or just flow. Okay, let's read the statement together. An observer with a detector standing on the side of a straight road is stay, yeah, standing. So if I'm standing, my velocity will be equal to 0. And then records the frequency of the police car siren, whatever you pronounce it as, moving in a straight line on two separate occasions. On two separate occasions. Okay. They're just saying on two separate scenarios. Okay. The police car moves at a constant velocity. Its velocity is not changing. We just don't know. They just said constant velocity on both occasions. And then the results are shown on graph A and B below. So those occasions, now I can conclude, or in those occasions, because the person was standing aside of the road, the person was standing, right? Then what might have happened is that the police car was moving towards him like that. Then this is occasion number one. Then on occasion number two, the police car moved towards that person. It is now moving away from that person. So which means this is occasion number two. And we just don't know which scenario shows we just don't know which scenario shows occasion number one and occasion number two on graph A and B, right? So now you need that knowledge. You need that knowledge to know, Uri, when maybe a sound source is moving towards an observer, the frequency is higher or lower. You need that knowledge that I was telling you there, I was giving you. But now let's interpret the graph together. This is a frequency versus time graph, because here we have frequency, here we have time, right? Then for both graphs, graph A and B, but we are given certain value of frequency on graph number one. We are given this value, which is 1100 hertz. We are also given this value, which is 900 hertz, right? So those are the frequencies that are detected. Okay, those are the frequencies that are detected. But this FO, if you can see it, you have something like FO is a dotted line. This one. That is the frequency of the sound source. Let me remove everything. That's the frequency of the sound source, or the frequency that is being released. Someone might be asking Muri, why and how am I concluding that? Because in both scenario A and B, that frequency is remaining the same. It is not changing. You see, it has remained the same. It doesn't change. So when you cannot expect a car, maybe you cannot expect an ambulance that is releasing a frequency. Then after a while, maybe it is releasing 50 hertz. After a while, it is now releasing 100 hertz. That won't make sense, because what we're doing now here, what we're doing here, that is actually a sort of an experiment. It is an experiment, right? So if the values of the released frequency or the frequency of the sound source are fluctuating, the results that we're going to get are not going to be reliable. From life science, in order to get reliable results, we should maintain a constant value throughout the experiment, right? So that is why I concluded that this is the frequency of the listener, frequency of the listener, and then now it is frequency of the listener again. But what you will see in scenario number one, frequency of the listener, frequency of the listener, it is greater than frequency of the sound source. This is graph A, graph number one, the graph number A. And then in graph number B, the frequency of the listener, it it is less than the frequency of the sound source. Why am I saying that? Because it starts at 0, right? And then this might be 100, this might be 200, this might be 400, and so on. Then here it might be 0, and then 500, and then 900. This might be 1200 or something like that. That is why I'm saying in graph number A, the frequency of the listener is greater than the frequency of the sound source. And then the frequency of the listener in graph number B, it is less than the frequency of the sound source. Are you all fine so far?
Yes.
Okay, thank you. So now 6.2. I'm not going to talk about 6.1. I never loved that definition. I think you take 2 or 3 minutes writing that definition. Yes. So which graph, A or B, shows a police car moving away from an observer? Yeah, now let's talk. Which graph, A or B, shows a police car moving away from the observer? Which graph? Just raise
Is
up
it?
your hand. Okay, you can answer.
I think it's B.
Reason. We need the reason.
Um, the frequency of the source is greater than the frequency of the listener because
Yeah,
that like is puzzle. Yeah.
yeah, that's correct. It's number B. Because for number B, the frequency that the person is detecting or the listener is hearing, it is now less than the frequency of the sound source. So which means graph number B shows um, a police car moving away. B. And then the reason you can just say frequency of the listener is less than the frequency of the sound source, or the frequency of the sound source is greater than the frequency of the listener. You just need to know how to interpret this sign. I don't think I have to write the reason. You can write the reason for yourself. Yeah, that's it. So okay, let's move if we're all fine with 6.2. But 6.3, calculate the speed of the police car. The speed of the police car. Take the speed of sound in air to be 340 meter per second. Mhm. Calculate the speed of, oh, okay. Oh, I see now. So in this case, this is where you're going to introduce simultaneous equations. And I was even going to forget about simultaneous equations in this case. Okay, because in scenario number one, we have to all agree that this is where now the police car was moving towards the observer. The police car was moving towards a stationary observer, right? So you're going to say 6.3. You first write them the formula, the actual formula. It's equal to V plus or minus V, is it V listener, right? Yeah, VL over V plus or minus VS multiplied by FS right there. So our listener in this case is stationary in both cases, right? Then you're going to write the first formula, or you're going to derivate the formula and write the formula as V over moving towards, it's a V minus. When it is moving towards a stationary observer, we say minus, then VS multiplied by FS. Now you just play with substitutions. What do you have? You have the frequency, you have the frequency of the listener, which is this one. You have the frequency of the listener, which is 1100. Is equal to, what is the, yeah, you see, they gave you the speed of sound in air, which is 340. So you're going to say 340 over 340 minus Vs. You are looking for the speed of the sound source, which is the police car. You don't know. So you are going to say, what is the frequency of the sound source? We don't know. They just said F0. So we don't know it. We're going to say frequency of the sound source, right? Now, I think it's a matter of simplifying the equations. Guys, I want to show you a trick that won't give you more time in exam. When you arrive in this case, when I just go and cross multiply, you're going to cross multiply this 340 minus Vs to the other side. So you're going to say 1 100 into 340 minus Vs is equal to 340 multiplied by Fs. This is your equation number 1, right? Just do it like this. Then for the second graph, we can have another equation in this graph. We can take another equation. So for the second one, you can repeat the formula if you want. So now I'm going to repeat the formula for you. Frequency of the listener is equal to the speed of sound in air, and then speed of sound in air plus velocity of the sound source, because it is now moving away. Then multiply by frequency of the sound source, right? That is my scenario. That is my graph number 2. Then, which means I'm going to say now 900. That is the frequency of the listener is equal to 340 over 340 plus Vs, because I don't know, multiply by Fs. So now you cross multiply again. We're going to say 900 into 340 plus Vs, close brackets, 340 Fs. This is your equation number 2. You see now, so if you look at equation number 2 and equation number 1, I have something like this, 340 Fs. That thing is common in both of the equations, you see. So which means I can just equate equation number 1 and equation number 2, because I have this. Look at this. I have 340 multiplied by Fs, which is equal to 340 multiplied by Fs, right? So I can equate those two things because they're equal. Then when I equate them, I'm going to have 1100 into 340 minus Vs is equal to 900 into 340 plus Vs. Are we still together? Are we still all fine here? So far, then one is lost. Thank you. Okay, so now you can just divide both sides by 900. Divide both sides by 900 because 900 is less than 1100, which means if you divide here by 900, you also divide here by 900. What do you actually divide? You're going to say, to make your calculations simple, when now you're going to say 1100 divided by 900, what is the answer? 1100.
It's 1,22.
It's 1,22. Don't give me the entire thing. Just keep it in your calculator. I will take it like this. This is going to be 340 minus Vs, close brackets, is equal to 340 now plus Vs. Now we are just going to play around with mathematics. We are going to say 1,22 something multiplied by 340. What do you get? I'm multiplying out the brackets.
450,5
415,
50,
comma,
56.
56. It's fine. Minus 1,22 Vs. That one is fine. And then is equal to 340 plus Vs. So now you are going to take this one to the other side, and then you take 340 to the other side. Like you take constant values to one side and then variables to the one side. So by that I mean we are going to say 1,22 plus vs. This is vs also. 1,22 vs is equal to 3, oh no, 415,56 minus 340. So what is 415? 415 minus comma 56 minus 340.
75,56,
75
56.
comma 56. Okay. And then what about this one? 1,22 plus 1. I think it's going to be 2,22 vs. Then you're going to divide both sides by
Yes,
2,22. 2,22. What is the answer for V?
I got 34,
How
comma
much?
0,
25.
34,
34,
comma 04.
04 meter per second. That is your velocity of the sound source. So far everyone is still good, right? Where are you having a problem? Talk to me. Are you all fine?
Yes.
All right. All right. That means I'm moving, I'm moving, I'm moving, I'm moving. I'm moving.